The solar system has a new member, and it is calling into question theories about the much-debated Planet Nine. Using the Subaru telescope's wide field of view, astronomers have spotted a tiny far-off world beyond Pluto, one that could reveal how the outer solar system evolved into its present form. The strange object dubbed ammonite was discovered through the Fossil Project. Observations in March, May and August 2023 first picked up the object, now catalogued as 2023 K14. By July 2024, astronomers turned the Canada-France-Hawaii telescope toward its predicted position, and fresh images confirmed the speck was still creeping along its lonely route. The team also identified older, previously overlooked sightings of the object and archival data from other observatories. This enabled them to track the object's path across nearly 2 decades. With nearly 20 years of motion now mapped, its path proved so remote and eccentric that astronomers placed 2023 KQ14 in the elite Sednoid Club, a very rare category with only 3 other known members. Using the supercomputers at Japan's National Astronomical Observatory, the fossil team ran tests that traced its path. The simulations suggest that 2023 K14 has followed a stable orbit for roughly 4.5 billion years. Yet today, it follows an orbit different from the other Cedoids, indicating that the outer solar system is more complex than previously thought. But most importantly, this discovery sets new limits on the hypothetical Planet Nine. The closest 2023 KQ14 ever gets to the Sun is about 71 astronomical units, which means that even at that distance, it is 71 times farther from the Sun than Earth. But since Ammonite's orbital path is highly elliptical, it gets as far from the Sun as 432 astronomical units, and it takes about 4,000 Earth years to complete one orbit of the Sun, which means that when workers first laid the stones of the Great Pyramid, Ammonite had just begun the same 4,000-year lap it is now finishing. Fascinating, isn't it? One Ammonite year spans nearly all of recorded human history. According to the lead scientist, it was found in a region far away where Neptune's gravity has little influence. And that implies that something extraordinary occurred during the ancient era when Ammonite formed. The fact that 2023 KQ14's current orbit does not align with those of the other 3 Cedoids lowers the likelihood of the Planet Nine hypothesis. He added, "It is possible that a planet once existed in the solar system, but was later ejected, causing the unusual orbits we see today." So, what does this mean for Planet Nine? Well, Planet Nine might still be out there, just much farther from the Sun than first thought. It may even have been flung away long ago, leaving only its gravitational footprints behind. Another idea is that a passing star billions of years ago tugged Ammonite and the other Cedoids onto their unusual paths. A passing star's impact on Planet Nine. This is exactly what another recent study showed. Our star system appears to be a calm and stable place. Yes, there are times that the gas giants occasionally nudge a comet or asteroid out of their orbits, sometimes even sending them hurtling towards the direction of the Earth. But overall things have been generally stable. But the Milky Way is estimated to contain around 200 to 400 billion stars, with the solar system orbiting through the galaxy. While the distances between stars are huge in an ocean of these celestial fireballs, the chances of them coming close to each other cannot be ruled out. Now, around 75% of the stars in our galaxy are red dwarfs, typically having around 8% to 40% of the Sun's mass. The Milky Way itself spans a massive area stretching about 100,000 light-years across with a central bulge, roughly 5,000 to 8,000 light-year in radius. When calculating how often stars come close to our Sun, we consider factors like the density of stars in different parts of the galaxy, their orbits, and how fast they move relative to each other. On average, stars travel at around 20 km relative to the Sun. Using this data, scientists can estimate how often stars pass near the solar system, potentially affecting our cosmic neighborhood. Calculations suggest that the closest a star has likely come to the Sun was about 500 astronomical units, roughly 10 times the distance from the Sun to Pluto. Such close encounters are rare, occurring once every few 100,000 years, so it's highly unlikely that a passing star will disrupt the orbits of planets in our solar system. But while encounters with stars won't often cause direct issues for planets, they may disturb the Oort cloud, a distant region of icy bodies surrounding our solar system. We know that gravitational interactions between stars and the Oort cloud are always happening, but their effects may not be visible for millions of years. Over time, passing stars can send these icy objects hurtling toward the inner solar system, increasing the chance of cometary impacts. The last known star to pass close to the Sun was Scholz's star, which came near us about 70,000 years ago. However, a new research suggests that a star may have come closer to Earth than the Voyager probes. Our solar system may have had an incredibly close encounter with another passing star. Not one, but two recent studies propose that a stellar flyby could account for the strange orbits of certain objects on the outskirts of our solar system, as well as some of the unusual moons orbiting nearby planets. This encounter, according to the research, was astonishingly close. A rogue star passed within 110 astronomical units of the Sun, meaning it came 110 times the distance from the Sun to Earth. To give some context, this star would have approached us even closer than the Voyager 1 probe, which after being launched is now 164 astronomical units away on its journey beyond the solar system. Given that the nearest star to us today, Proxima Centauri, is more than 4 light-years away, this was an incredibly close call. Such a near miss, the researchers suggest, would be necessary to explain the unusual and chaotic orbits of celestial objects located in the farthest regions of our solar system beyond Neptune's orbit. To investigate whether a passing star's gravity could be responsible for the unusual orbits of some of the trans-Neptunian objects, the scientists ran over 3,000 computer simulations. Their findings not only confirmed the hypothesis, but revealed something fascinating. The simulations showed that this stellar encounter could explain two of the most peculiar trans-Neptunian objects which have retrograde orbits, meaning they move in the opposite direction of the planets. It could also account for the distant dwarf planet, Sedna, which orbits as far as 937 astronomical units from the Sun. A Mythgoin co-author and astrophysicist noted that the simulations pointed to a star slightly smaller than our Sun at about 0.8 solar masses, passed within a little less than 4 times the distance from the Sun to Neptune. Interestingly, this event could also explain the strange moons in our solar system, such as Saturn's moon Phoebe, which has a retrograde and distant orbit. Similarly, Jupiter and Neptune host several irregular moons that could have been trans-Neptunian objects displaced by the gravitational influence of this stellar flyby. This could explain why the outer planets have 2 distinct types of moons. Regular moons, which formed along with the planets and have stable, predictable orbits, and irregular moons, which have strange or retrograde, that is, backward orbits, and may have been captured from the outer solar system. If this star had a close encounter with our solar system billions of years ago, it could be a remarkable chapter that may have been overlooked. But what if Planet 9 is still here? Astronomers have been looking for something big, something strange hiding far beyond Neptune. But spotting it is extremely difficult as it doesn't show up in any images. But its influence is felt in the orbits of distant icy bodies. Scientists call it Planet 9, and they have been hunting for it for years. And recently, while searching for signs of this elusive 9th planet, astronomers stumbled upon something unexpected and extraordinary. This 2171, a newly discovered dwarf planet candidate. But it isn't just an addition to the list of distant dwarf planets. It might be pointing to something inconvenient, something that could contradict the very reason we started searching for Planet 9 in the first place. New dwarf planet challenges Planet 9 theories. Astronomers have just identified what could be a new dwarf planet using observations from the Dark Energy Camera in Chile and the Canada-France-Hawaii telescope. The discovery wasn't made through a single lucky image, but by carefully analyzing 7 years of archival data, which revealed 19 separate detections, enough to reconstruct its orbit. And once they mapped it out, they found the object follows an extreme orbit. 2017 travels in a long elliptical path around the Sun. At its closest, it comes in at about 44.5 astronomical units, just a bit beyond Pluto. But at its farthest, it swings out past 1/600 astronomical units. For scale, that's over 50 times farther than Neptune, and one orbit takes about 25,000 years. That's not just far. That's outer or cloud territory. The object itself is estimated to be around 700 km wide. And the interesting thing is it's not interacting with Neptune. It's just out there. No one's sure how an orbit like this even formed. One idea is that 2017 OFF201 had a close run-in with something big. Maybe a planet that flung it into this stretched-out path. Now, over the past several years, astronomers have picked up on something unusual. A handful of distant objects beyond Neptune, known as trans-Neptunian objects or TNOs, weren't behaving the way you'd expect. Instead of having orbits pointing in all directions, a surprising number of them were aligned in similar ways. Their orbits were clustered, tilted, and stretched in the same general direction. And when that happens in space, it usually means something massive is influencing them, something we haven't seen yet. One idea was that a giant planet 5 to 10 times the mass of Earth was out there, disturbing their paths. That's where the whole Planet 9 theory comes from. But here's the twist: 2017 doesn't follow that pattern. Its orbit is totally out of alignment with the others. And that is a problem because if Planet 9 exists, and if it's the reason for the orbital clustering we've seen, then objects like OF201 shouldn't exist, at least not in a stable orbit like this one. In fact, simulations show that if you add Planet 9 into the model, OF201 gets kicked out of the solar system within 100 million years. So now we have a contradiction. Either this object is a fluke, or the Planet 9 model needs serious revision. And it doesn't stop there. 2017 OF201 spends only about 1% of its orbit close enough to be seen, which means we may have just caught it at the right moment. And if that's the case, it could be just the tip of the iceberg, suggesting there might be dozens, maybe even hundreds of other objects out there with similar orbits and sizes still hidden in the dark. Right now, the dwarf planet is relatively close to the Sun in the sky from our point of view on Earth. That means the researchers need to wait about a month or so before they can conduct follow-up observations. And they are also hopeful that they can eventually secure some time to scan the object using the James Webb Space Telescope. Till then, the possibility of Planet 9's existence is still on the table. Here's how. The simulations only used one specific location for Planet 9. But not all scientists agree on where the hypothetical planet lurks. In fact, Konstantin Batygin, one of the scientists who first proposed the existence of Planet 9, says that the discovery of 2017 F21 doesn't prove or disprove anything. Speaking with NBC News, he said, "The objects in the outer solar system that are likely to show a footprint of Planet 9's gravity are the ones where the closest points on their orbits around the Sun are still distant enough that they don't strongly interact with Neptune. This one unfortunately does not fall into that category because its orbit is very chaotic." Meanwhile, Sai-Hao Chang, who led the discovery of 2017 OFF201, said that he has not abandoned the hope of finding Planet 9, as the whole project started as a search for it. So, if you're holding out hope for a ninth planet in our solar system, don't give up just yet. What do you think? Just because we found something unusual doesn't mean it's the thing we've been looking for. Either way, one thing is clear. This mystery dot